Student page 124. I've gone ahead and decided to assign 0 for x and y in 2x minus y is less than 3. So 0 minus y less than 3. That means the opposite of y is less than 3. Remember, we're going to change signs. We're going to change everything. Y is going to be greater than negative 3. So we're going to put a negative 3 in here. Now, if y is 0, we're going to get 2x minus 0 is less than 3. And that tells me that 2x is less than 3. X is going to be less than 3/2. So we got 3/2. We'll graph those 2 points in a minute. But 0, negative 3 right here. And 3/2, 0 right here. 3/2 is 1.5. It's between 1 and 2. All right, let's go ahead now and graph our next one. And we're going to put 0 in for x. That gives us 0. That did not work. This gives us 0 plus 3y is greater than 0. And that tells me that 3y is greater than 0. Y has to also be 0. Oh, well, that just messed up this whole guy, because if I've got 0, 0, I'm going to have to come up with some other point. So what if I pick, let's say I pick 3 for x. So I'm going to get 12 plus 3y is greater than 0. That means 3y is greater than or equal to negative 12, and y is greater than or equal to negative 4. Now I have, so 0, 0, and 3, negative 4. I'm going to go ahead and get these two lines graphed. Notice a solid green line for the 4x plus 3y greater than or equal to 0, that's why it's solid, and a dotted line for 2x minus y is less than 3. If I think about 0, 0, 0 minus 0 is less than 3, that's true, and that tells me that I'm just going to shade this side. I'm going to just go crazy wild with shading this side. Here we go. Whoop, a little too long, but you get the idea. And then I'm going to go ahead and check the other one, figure out where that goes. So I can't use 0, 0. It's already in there, but I could use, well, let's make this easy. Let's go 2, 3, 4, 5. Let's test with 5, 0 here. Okay, so 5, 0 is, let's see, 5, 0. 4 times 5 is 20. 20 plus 0 is greater than 0. That's true. So I can go ahead now and put a bunch of lines here showing that this is where my shading is. And we have to really look to where the double hatched area is, because this is much more of the focus for where we're going. And so our final answer, we would really want to emphasize that this area in here is where the solution to both inequalities is. I hope you like that. A small project for us. We're going to graph the solution set to this system of inequalities, and I've gone ahead, I'm going to put 0 in for x and y. If I put 0 in for x, I get 0 minus y is greater than 5. The opposite of y is greater than 5. That means y is less than negative 5. So we got a negative 5 here, and if we put 0 in for y, we get x is greater than 5, so we get a 5 here. Okay, well, this is one of the funner things we've had to graph. 0 and negative 5, that's right here, and 5, 0 is right here. We'll go ahead and put the dotted line in a minute. Now, the interesting thing is this next part of the question where it says x is greater than negative 1. Notice there's no y in here. That means that we have to go through where x is negative 1. Well, x equals negative 1 here. And if we think about it, this is negative 1, 3 here. That's x is negative 1 there. This is negative 1, negative 5. So whenever we graph and we only have one variable, we're going to be perpendicular through the axis mentioned. I'm going to go ahead and get the lines in here. So we get the lines for both of our equations. And what we have is we have x minus y is greater than 5. So let's see, 0, 0. Is 0 greater than 5? And the answer is no. That means I'm going to be shading below this line. This is the side that's got to take the color this time. And then the next one, x is greater than -1. Well, anything positive is greater than -1, so it seems that the best thing would be to shade this way. And we can begin to see where our answer takes shape. Our answer is kind of bordered by this line and this one. Let me go ahead and pick a color that'll emphasize this so that really we're looking at what's in here and here, whoops, and here with a dotted line. Let me just go ahead and make some shading colors here. We're going in with all this, and then it stops abruptly and it comes straight down as this line comes down. And this would be the area where we have an intersection. Very good. Last question. Leave up the ante. Now we've got 3 lines, but that's kind of going to be interesting to see what happens to. I've gone ahead and show 0, 0. So if 0 is x, y is going to be less than 4. If y is 0, then x will have to be at least -4 in order to work. All right, 0, 4 up here, and -4, 0 back here. Nice. Okay, we'll come back to that one in a minute. Let's go ahead and take a look at the next one. 0 in for x would give us a 4, and 0 in for y would require a +4 as well. Very interesting. So we have a little bit of an overlap here. We got a green, purple, and then we got a 4 here. Did I count that one right? Yep, okay. And then interestingly, we have y is greater than 0. So y is greater than or equal to 0. Well, the places where y is greater than and equal to 0 is this whole upper plane, quadrants 1 and 2. So we'll draw a line and shade. I'll get that for you in a sec. Let's go ahead. Notice I've gone ahead and drawn in the y is greater than 0. And we're going to examine y is less than or equal to x plus 4. 0, 0. Is that true? Is 0 less than what's left 4? And the answer is yes. So that's going to give us shading on this side. This is getting very colorful. It's nice when you have 3 colors. There we go. And now I'm going to go ahead and check the final question. And it says, if we put 0, 0 in here, is 0 less than 4 minus 0? Is 0 less than 4? Yes. 0, 0 is here. We want to shade over the 0. We want to cover it up. That's how we show which half plane we want. And here it is. And we have a glorious mess. And let's go ahead and identify where that mess is. So this is the region where all 3 colors overlap. Hope you see it. I'll go ahead and emphasize it a little bit with this orange. And ta-da, we have the answer. Good job.